All right, we just took a really close look at how horizontal asymptotes work, what they look like as it moves to infinity. We use those limit properties. And in this example, we're going to actually check out vertical asymptotes as well, because those are also really important. And we're going to look at those asymptotes as we approach specific numbers from left and right. And so that's what the little plus and minus signs mean now under your limits. That just means that the plus sign means we're coming from the positive end of the number line, and the minus sign means we're coming from the negative end of the number line. And we're going to put those together, and we're going to see how these asymptotes look in limit form. It's really actually kind of neat. So we're going to define a vertical asymptote to be the line x equals a is a vertical asymptote of the graph of a function y equals f of x if either of these two limits exist. And so we've got both of these limits here written for us. Notice that this guy is going to come from the positive side of the number line. This guy is going to come from the negative side of the number line. And so that's kind of what we're looking for. Now, how about finding those vertical asymptotes? Well, sometimes it can be really hard to see, but what we have to do is we have to look at these guys in terms of those two specific limits. Now, where are we undefined right here? And the answer is we're undefined when x is 0. Okay? Can't have 0 in the denominator. So what we need to do then is look at the limit as x approaches 0 from the left of 1 over x squared, and look at the limit as x approaches 0 from the right of 1 over x squared. And so when we do this, what's going to happen is we get really, really close to 0. We're undefined there. We can't have 0 as part of our answer. But when we get really, really close to 0 from the left-hand side, we'll notice that the numbers, we're getting really, really small numbers on the top. So 1 divided by a really, really, really small number is a really, really, really big one. And so we're going to discover that this limit, whoop, that's the wrong color. We're going to discover that this limit right here is going to go to positive infinity. And I've got a graph up for you to see so you can follow this graphically. Sometimes with vertical asymptotes, it's a lot easier to see graphically. The same thing is going to happen with the blue limit. And the reason they both go to positive infinity is because if you take a negative number and square it, it becomes positive. Okay? Now, let's look at the tangent. It's a little bit different. And so what we're going to do is look at the graph of a tangent. And when you look at this graph of tangent, you'll notice that it makes the same shape over and over and over again. And you might remember this from last year also. You might remember this shape. And so what happens is as we approach odd multiples of pi over 2, odd multiples of pi over 2, we're going to be undefined, okay? And so then what happens then is we just have to look at what's going on both sides of the odd multiple. So the limit that we would set up for this guy, it's going to look a little bit weird, but you can see it on the graph, and it's going to be something like this. When x approaches that odd multiple, we're going to let that equal a. All the multiples of pi over 2 equal a. When we approach a from the left of tan x, and the limit as we approach a from the right of tan x. And what you're going to see is that on one of these, we're going to go to negative infinity, which will happen to actually be the positive side. And then on one of these, we're going to go to positive infinity, which will be on the left-hand side. And so it's a toughie, and it's a lot easier to see when you look at it with sine and cosine, but we've got to get where we can understand how tangent works too. So here's a real quick introduction then on finding vertical asymptotes.